So in this video, I'm going to review the basic concepts of chemical bonding. So basically, chemical bonds form because the system of atoms involved in the bond can achieve the lowest possible energy. So a lot of things in nature like to be at low energy. So we have two major types of bonds. The first one is ionic bonding, and this results from the electrostatic attraction between oppositely charged ions. So they form when we have one atom that likes to lose electrons and one atom that likes to gain electrons. And in most cases, this is a metal and a non-metal. So here we have sodium chloride. The sodium likes to give away electrons, so it becomes a positive ion, which is called a cation. And the chlorine likes to gain electrons, so it becomes negatively charged, which is called an anion. And so these oppositely charged ions attract each other, which is what holds them together in this bond. And so when we talk about the lowest possible energy, we mean the electric potential energy. And electric potential energy is basically energy that two charged particles have when they're close together, such as the sodium ion and chlorine ion. And so if we have two charged particles that are the same sign, both positive or both negative, then they want to repel each other. And if things want to repel each other, we say they have positive potential energy. However, if things have opposite signs and they want to attract each other, we say they have negative potential energy. And so you can see here, since the opposite signs, they have negative potential energy. So molecules want to have the most negative potential energy as possible. So let's look at what happens if we have two atoms that are the same type. For example, H2, which is two hydrogen atoms. So here we have a graph of the total potential energy of the two atoms based on how far apart the two atoms are. So let's look at each interaction between these two atoms. So first we have the two protons that want to repel each other, and also the electrons that want to repel each other. So these two repulsions create positive potential energy. And so we get negative potential energy from the attraction between the protons and electrons of the two atoms. So when the distance between the atoms is very small, you can see that the potential energy is very, very positive. And this is because the repulsive forces between the protons and the electrons and electrons overpower the attractive force between protons and electrons, which drives up the potential energy. And if the distance is too far, then there's almost no interaction between the two atoms, and so the potential energy approaches zero. So over here we have a spot where the distance is just right, and the potential energy is at a minimum. And so this distance, where the potential energy is at a minimum, is called the bond length. And so what's actually happening is, since the attraction between the protons and electrons creates that negative potential energy, which is what the molecule wants, it will maximize this attractive force by putting the electrons in between the two nuclei. So it's almost like the two nuclei are sharing these electrons. And so we call this type of bond, when the nuclei share the electrons in the space between them, covalent bonding. So covalent and ionic bonding are kind of two extremes of bonding, but there's a step in between where the electrons are not completely transferred, like in ionic bonding, but they're shared unequally. So this type of bond is called a polar covalent bond. For example, in HF, the bond is polar because the fluorine has a greater attraction for the shared electrons than the hydrogen. So it draws the shared electrons closer to it. And so this side of the molecule with fluorine will be slightly negative charged, while the side with hydrogen has a slight positive charge. And so this symbol just indicates a partial charge. So it's not quite a negative one or positive one, it's in between. And so electronegativity is a measure of an atom's ability to attract the shared electrons to itself when it forms a molecule. If we look at the periodic table trend of electronegativity, it tends to increase as we go from left to right across the period, and decrease as we go down a group. So fluorine is the most electronegative atom, followed by oxygen. So when a molecule has a center of positive charge and a center of negative charge, we say that it has a dipole moment. So as you can see here in HCl, the chlorine is more electronegative than the hydrogen. So this side develops a slightly negative charge, while the side with hydrogen develops a slightly positive charge. So we say it has a dipole moment. Sometimes, even if each bond is polar, the whole molecule does not have a dipole moment, because the polarities of each bond can cancel each other out. So for example here, each of these bonds between sulfur and oxygen is polar. The oxygen always has a slightly negative charge. However, since these oxygens are kind of symmetric, they're each at a point in an equilateral triangle. So these partial charges actually cancel each other out. There's no center of negative charge. It's all spread out evenly. So this does not have a dipole moment. This molecule does have a dipole moment because the positive charges are all on this side. So we can say the center of positive charge is somewhere over here, while the center of negative charge is on the sulfur. CH4 does not have a dipole moment, even though each of the hydrogens all have a partial positive charge, because they all cancel each other out. This is actually a three-dimensional shape. It's a pyramid with a triangular base. So all of these bond polarities cancel each other out because there's no center of positive charge. Over here, this CO2 also does not have a dipole moment because you can see the partial negative charges are too spread out. So in most stable compounds, atoms have a noble gas configuration, and they obtain this either by sharing, losing, or gaining electrons. So for example, the electron configuration of calcium is argon and then 4s2. So when calcium forms a bond, it wants to give away these two electrons so that its electron configuration is just that of argon. So it will give away two electrons when it forms an ionic bond. So now we're going to look at the relative sizes of ions. So as we'd expect, cations are smaller than their parent atoms because they lose electrons, while anions are larger because they gain extra electrons. So if we have ions that have the same number of electrons, which are called isoelectronic ions, for example O2 minus and Al3 plus, they have the same number of electrons. So to determine which one is bigger or smaller, we have to look at the number of protons. Because the more protons it has, the nucleus, since it has more positive charge, it will attract the electrons more closer to it, which decreases the size of the ion. So since aluminum has more protons than oxygen, aluminum will be smaller. So the last thing we're going to look at in this video is lattice energy, which is defined as the change in energy that occurs when separated gas ions come together to form an ionic solid. So basically this tells us how strongly the ions in the solid state attract each other. So here we have lithium and fluorine ions as a gas coming together to form lithium fluoride solid. And it tells us the change in energy, which is the lattice energy, is negative 1047 kilojoules per mole. So since this lattice energy is so negative, it means that lithium fluoride is a very stable ionic bond, because when it forms this bond, it's at a much lower energy level than it was before when they were separated.